Good afternoon, everyone, and welcome to our latest ECA Technical Tuesday webinar, our technical webinar series exclusively for ECA members. Today, we're looking at demystifying electric vehicle charge point installations with our technical manager up on your screen now, Curtis Jones. Hi, Curtis. Curtis, we'll look at some of the key requirements of section 722 of BS 7671. And we're going to explore ways of achieving compliance. Curtis is also going to look at requirements for PME earthing systems, how to select a suitable RCD, things to assess prior to carrying out installation works, and a whole lot more. So just before we start today's presentation and I hand over to Curtis, you should see a question mark button on your screen now. Do please make use of this at any point in today's presentation, and we'll try to answer as many questions as we can at the end of today's session. Finally, from me, today's session is being recorded and will soon be available on the members area of the ECA website because this is member exclusive. However, all of our publicly available webinars, such as the ECA Learning Zone series with our commercial associates, as well as our brand new weekly video updates from ECA staff, those are all available on our YouTube channel. That's at youtube.com/ECA Live. That's enough from me. I hope you enjoy today's presentation, and over to you, Curtis.
Cheers, thanks Omar. Good afternoon, everyone. Yeah, so today we're going to be looking at demystifying some of the requirements around electric vehicle charge point installations. So the demand for these kinds of installations continues to grow. So we're going to look at some of the key requirements, some of the common things that we picked up through maybe calls and emails and speaking to our members, areas we'd like to expand a little bit more and hopefully provide some further guidance on. So agenda today, I think Omar summarised it pretty much, but a little bit more detail on that. We're mainly going to be focusing on mode 3 charging. So we'll have a look exactly what that is. We're going to look at achieving compliance with section 722. So pulled out some of the key requirements within this section, some of the topical ones that seem to keep cropping up when speaking with members. There'll be some additional considerations that we'll look at for these kinds of installations. Then there'll be some food for thought, is how we've put it. So some things that might require some deeper thought, or maybe some things that you need to look at potentially avoiding when specifying, designing and carrying out these kinds of works. And as always, we'll finish off with a summary, and there'll be some time for some questions at the end of the presentation. And as Omar mentioned, feel free to pop those in as we move through the presentation. So the presentation, it will highlight some of the key requirements for EV charge point installation, so stuff that we picked up on from when speaking to members and things that we're seeing out in industry at the moment. So the presentation isn't intended to cover all technical aspects of EV charge point installation, so we have cherry-picked some key areas to focus on today. So as always, members should consult themselves of compliance with the relevant standards and legislation that could be applicable. Of course, BS 7671 generally seen as our starting block when looking at electrical installations in general, and of course applicable to EV charge point installations. If you're carrying out these kinds of installations or you're looking to move into them more, of course a growing and expanding market, then the IET have a code of practice available to you. So it might be a good idea to pick up one of those, which will also provide further guidance on the requirements for electrical charging equipment installations. So there may be some note to that code of practice throughout the presentation. There'll certainly be plenty of relevance to BS 7671. I'll be quoting some regulations. So if you've got your book to hand, feel free to follow along in that, and I can point you towards some of the relevant page numbers that we're looking at. And as mentioned a moment ago, the presentation will mainly focus on the requirements related to installations for mode 3 charging. However, some requirements might be general, that might be able to be applied to other types of EV charge point installations, or maybe some additions and alterations in general. Some points may be applicable to. So jumping straight into it, mode 3 charging. What is mode 3 charging? Well, as always, BS 7671 part 2, it sets our definitions for commonly used terms within the standard. It tells us that mode 3 charging is the connection of the EV to the AC supply network, utilizing dedicated electric vehicle supply equipment, where the control pilot function extends to control equipment in the electric vehicle supply equipment, permanently connected to the AC supply network. So to sort of simplify that, we're looking at dedicated EV charging equipment here, which are used in private installations generally, such as on people's homes, or maybe at people's workplaces and businesses too. So we're mainly focusing on the mode 3 type today. So moving to look now to achieve compliance with section 722 of BS 7671. So of course, parts 1 to 6 are the general requirements for electrical installations. Then we have part 7, which looks at different special locations and special types of installations. And these types of installations generally introduce additional hazards and additional requirements. So section 722 specifically looks at EV charging, and we're going to look at some of the key bits within here today. So initially, we're going to look at additional considerations for a PME earthing facility. And this is covered within regulation 722.411.4.1. And this regulation can be found on page 325 over onto page 326. So this regulation is relevant to PME earthing systems, where you're looking to put a charge point on a PME system, that this charge point is to be located outdoors, or it's expected to be used outdoors. Now, the information on screen, the text and the image, are both taken from the code of practice. So the text pretty much summarizes the key information within 722.411.4.1. So I've opted to just place sort of a summary on that. Again, those following in the book, page 325, 326, will see this regulation spans over nearly a page and a half of BS 7671. So probably a bit text heavy to be popping onto a presentation. But we're going to look to summarize these requirements. So PME earthing facility, where the charge point could be located outdoors or is expected to be used outdoors, cannot be used to power EV charging equipment or to supply EV charging equipment unless one of the following 4 conditions is met. And these are indent 2 to indent 5. Now, you'll see I've got indent 5 highlighted up. So my main area of focus will be on that, because it's probably the most common measure applied when looking at our mode 3 charging there. So we'll summarize the first few to start with. So indent 2 looks at adding an additional earth electrode to the PME earthing arrangement. And the image to the right of the screen pays relevance to this. Now, this requires the earth electrode resistance of the earth electrode to be added to be at a very low value, which in most types of installations is very difficult and impractical to achieve due to maybe the type of ground, or maybe the difficulties of even having to bury an earth electrode. So unlikely that it's used, but it is a possibility. So indent 3 is the first of looking at voltage operated devices. And this monitors the voltage between the general mass of earth and the protective conductor at the charging point, and should disconnect if the voltage difference exceeds 70 volts RMS. Again, this is not one of the more common measures to use, and it may, subject to manufacturer's instructions, also require an additional earth electrode to be installed. Indent 4 describes a voltage operated device, but this time looks at the line to neutral voltage, and the charging point again should operate, and the charging point should disconnect once this voltage range goes outside of a specified range. And some EV charging equipment may use to provide protection via indent 4. As mentioned, indent 5 is probably the most common measure applied here to achieving compliance with this regulation. And it describes a device for detecting open pen conditions that provides no less degree of safety of those listed in indent 3 and indent 4. So following on from this regulation on page 326, there is a note, and then there is further information provided within this clause of the regulation. So it discusses where equipment is not covered by British or harmonised standards. So the device just referred to in indent 5 of regulation 722.411.4.1 relating to the open pen device is not currently covered by a British or harmonised standard. So when selecting a piece of equipment that isn't covered by the British or harmonised standard, it is the responsibility of the installation designer or other person responsible for specifying the installation to establish that this equipment is suitable to provide the relevant protection and to be used to fulfill the requirements of this regulation. Some of the things that the installation designer would have to confirm is that the equipment meets the requirements for the electrical equipment safety regulations, the electromagnetic compatibility regulations, and any other relevant legislation. Additionally, the equipment should have either a CE, UKCA, or UKNI mark, and importantly, a declaration of conformity should be available. So this declaration of conformity is required to be appended to the certification as part of the initial verification process. Where the above is satisfied, this is then not considered a departure from BS 7671. So the reason I focus on this point so heavily is that feedback we're getting from out in industry, from maybe assessors that are carrying out the early assessments, is that some installers are selecting suitable equipment to meet the requirements of this regulation that meet indent 5 with the open pen device. However, they are failing to provide or obtain this information from the manufacturer and then provide it to the client with the certification as part of the initial verification and handover process. So it's important when you're selecting this equipment, you're obtaining the information from the manufacturer and handing it over as part of the handover process with your initial verification documentation. Additionally, what we've also found is sometimes that designers and installers are assuming that this open device is fitted within the EV charging equipment, and they're not carrying out their due diligence and not carrying out the checks and confirming with the manufacturer that that protection is provided. Some of these installations are then going into service, and it's then being discovered at a later date that this hasn't been achieved, which of course would be non-compliant with the regulations and introduce a potential risk to the installation. So we sort of stress to members, ensure that you're carrying out and having these conversations with the manufacturers if required, obtain this information and attach it with the relevant certification as part of the initial verification process. Okay, so that sort of covers PME outdoors. So we're going to move to now selecting a suitable RCD. So a very topical point of conversation in general, I think, when looking at EVs and maybe other renewable technologies at the minute, but obviously focusing on EVs today and selecting a suitable RCD. So within page 327 of BS 7671, regulation 722.531.3.1 tells us that RCDs shall disconnect all live conductors. So in order to fulfill compliance with this regulation, you need to ensure that your RCDs protecting the EV charge point equipment will disconnect all live conductors in the event, let's say, of a fault occurring. So we've got two images up on screen now. The image to the left shows what we call a single pole device. So you'll see that the neutral conductor is permanently linked on the supply side to the neutral conductor that would be connected on the outgoing side of the device. And then the switch conductor would purely be the line conductor, that would occur and make it a single pole device. Now, the image to the right shows a single pole and switched neutral device. So in the event of a fault happening here, both line and neutral conductors would disconnect. So we call it a single pole and switch neutral because the overcurrent protection is in the line conductor, and that is signified by the curve symbol here for protection against overload, and then the protection against short circuit shown here. So it's important when we select these devices that we're ensuring they are suitable to disconnect all live conductors. Now, the devices shown here are typical images that you would find on RCBOs. So what you might protect, let's say, with a typical RCBO for a single phase circuit. Just to point out, this regulation does also apply to if you had a three-phase charging point, as of course it should disconnect all the line and neutral conductors supplying that equipment. Okay, so just following down onto the next regulation within BS 7671 here, so sticking on page 327, and this is again looking at selecting a suitable RCD. So we already know we need a device that switches all the live conductors, but there are additional considerations that you need to look at when selecting your RCDs. So it tells us within 722.531.3.101 that unless supplied by a circuit using the protective measure of electrical separation, each charging point incorporating a socket outlet or vehicle connector complying with BSCN 62196 series shall be protected individually by an RCD of type A, type F, or type B, and have a rated residual current or residual operating current, not exceeding 30 milliamps. So just a few things to highlight here. So firstly, it relates to each charging point. So it doesn't specify the circuit, it is the charging point that requires this protection from the RCD. And we'll go into that in a bit more depth in a moment. Now, the things I want to highlight at the moment, though, is the RCD type. So this regulation is clear that the RCD either needs to be a type A, type F, or type B, and it can't exceed 30 milliamps. Now, ECA has a guide available to you. There's sort of a bit of a hyperlink at the bottom, which of course you can't click at the minute, but we will pop the links in the chat a little bit later in the presentation. Excuse me. So ECA has a guide to the different types of RCDs, the things you need to consider when selecting these, and how the different types operate and work. So we know now we need to do either a type A, type F, or type B. How do you know which one to select for your EV charge point equipment? Well, again, this is where conversations with your manufacturers are going to be key, consulting that manufacturer's data to confirm which device is required for the specific EV charging equipment. It also provides some further clarity and information within this regulation and sort of narrows it down to what you're actually going to need. So it tells us, except where provided by the EV charging equipment, protection against DC fault currents shall be provided by either a type B RCD or an RCD type A or type F in conjunction with a residual direct current detecting device known as an RDCDD, and this RDCDD shall comply with BSIEC 62955. And again, it alludes to recommendations of the manufacturer of the charging equipment. So I think commonly found in a lot of charging equipment is an RDCDD device, then it's required to be accompanied by a type A or type F device. Every time I seem to do one of these webinars, the phone goes. So yeah, selecting a suitable device, consulting the manufacturer's data is going to be critical to this process. It's either going to need to be a dedicated type B or a type A or a type F in conjunction with an RDCDD device, and getting that clarity from the manufacturer is going to assist with the selection of that equipment. Now, sticking with this regulation, there's some further detail that accompanies it. So it tells us that RCDs shall comply with one of the following standards. This is BSEN 61008-1, BSEN 61009-1, or BSEN 60947-2, or BSEN 62423. So this regulation is quite clear. We need a suitable type of RCD, and this RCD shall meet one of the following standards. This is a shall requirement, which means it needs to be fulfilled in order to achieve compliance with the regulations. So we urge members to confirm that the RCDs that they're selecting meet the relevant British standards, British and European standards as required by this regulation. So some EV charging equipment has inbuilt RCDs. So if your EV charge point that you're installing or specifying has an inbuilt RCD, you need to confirm that this RCD meets one of these standards. So if it's a proper dedicated RCD, a bit like the one shown on screen here, and that's within the device, that could be perfectly fine, providing it meets those standards. However, often devices that are built within EV charge point equipment are integrated into printed circuit boards, known as PCB devices. And these may not fully conform to the standards listed on screen, for example, BSEN 61008. And what we sometimes find with this, sometimes the manufacturer may make statements such as they are PCB compliant to BSEN 61008. And this then leaves the installer in a bit of a tricky position, because it seems that they may be partially compliant and they may meet elements of the standards. But from our point of view, they're either compliant or they're not. So do they meet that standard? Can the manufacturer provide clarity that it meets BSEN 61008 as an example? From our perspective, the regulation here is quite clear that the RCD shall comply with one of the following standards. So if you looking to achieve compliance here, you should confirm that the device meets one of those standards. Now, some further information around this that provides some further guidance here, and that's in Note 3. Note 3 tells us an RCD of Type A or Type F in conjunction with an RDC-DD can be arranged with the RDC-DD inside the EV charging equipment. So as mentioned earlier, it's quite often these RDC-DD devices are within the EV charging equipment. And then the Type A or Type F RCD upstream, so before there, either in the charging equipment, again, that can be fine if it's a suitable RCD, or within the installation. So it may be that you need to put it within the installation itself. So it may be that you elect to put it within the consumer unit at the origin of the circuit. But just to provide a bit of clarity on that, the requirements of this regulation that are sort of referred to on the previous slide is to protect the charging point. It doesn't necessarily have to be at the origin of the circuit, unless, of course, maybe your installation method, maybe you've buried a PVC cable in the wall, for instance, your installation method may have specified it because of other requirements earlier on in BS 671. So to sort of summarise this bit, RCDs, they need to be of a suitable type, they need to switch all of the live conductors, and they should meet, or they shall meet, required British and European standards. So those are the key bits of focus from section 722. I'm now going to look at some further considerations. So we've looked at how there's additional requirements where the EV charge point is supplied from a PME system, where that equipment is to be used outdoors. However, if we have other earthing systems, it could significantly simplify the design. So this could be for maybe TT or TNS. So I'm going to do an example based on a TNS system where there is a private 11 kV transformer. So we know on the site, maybe it's a large commercial premises or large industrial premises, that we've got a dedicated, reliable TNS system. If this is the case, the information just referred to in regulation 722.411.4.1 which was all around PME earthing systems, that's no longer a consideration. So that may help to simplify your design, because you haven't got to consider additional equipment to maybe operate in the event of open pen conditions. So I think carrying out a pre-work survey, assessing the type of earthing system you've got, could help you to maybe simplify your design and simplify the type of equipment that is required, which of course then may reduce costs of the installation, which then you can pass over to the client. There are other systems as well. There's PNB systems, known as protective neutral bonding, and ECA have a guide to PNB systems available to members. Additionally, we've also got PME systems that may be inside buildings, and a common one of that could be inside a multi-storey car park. Again, the regulation around PME I referred to earlier was around outdoor charging points. So you may be able to simplify your design considerably when you have this system present inside of the building. Okay. So next point we're going to look at is the correct notification process. And again, this is something that you need to look at doing as part of your pre-work survey prior to going to actually carry the work out in itself. So when the maximum demand is less than or equal to 60 amps, notification to the DNO can be completed within 28 days of installation. So if following the additional demand of your EV charge point, if the demand is still going to sit below 60 amps, you can install the EV charging equipment and notify to the DNO within 28 days of that installation being complete. However, where the maximum demand is in excess of 60 amps, notification of the addition is going to need to be carried out prior to installation. So the network provider, the DNO, can confirm that it's going to be suitable to go and add that additional loading to the existing system. Now, there is a website link on the PowerPoint at the minute. If you want to have a look at further guidance and information around that notification process, that can be found on the Energy Networks website. So something else to add around the notification side of things. And that might be when you go out to the site, you go and visit the site, look at the supply parameters, you may find that you have a loop supply. Again, this is going to require a conversation with the local distribution networks prior to the works being conducted. So even if that demand is going to sit below the 60 amps, the notification to the DNO in this case is going to have to be before, because of having the loop supply. So loop supplies may require additional infrastructure work on the network to allow for the addition. So the DNO needs to confirm that the existing supply is going to be suitable for that additional demand. So in many cases, it could be a good idea to have the conversation with the supply network prior to the addition of the EV charging equipment. Okay, so finish off now with some food for thought and some things that might require some additional consideration. So I think one of the main, I think looking at it, this adding EV charge points or EV charging equipment to existing installations, this can often bring some difficulties for the designer or the installer who's looking to go out and carry out the addition. And we have seen many examples where EV charging equipment, additional termination blocks have been added to meter service cupboards to allow for the additional equipment. And it's worth pointing out that meter service cupboards are provided to allow for the installation of distributors and metering companies' equipment. So ECA would advise against locating equipment in this location, as it could go and cause problems in the future where distributors and meter providers look to maintain their equipment, or they may look to upgrade their equipment. And it may be that then 2-3 years down the line, after carrying the installation out, you're getting a call back off your client because you need to now move this equipment. Again, ECA have a guide available to members for the use or on the use of consumers' service cupboards. Okay, so the next point I'm going to look at is the use of insulation piercing connectors. And again, this is probably looking at when adding EV charge points to existing installations. There can be difficulties in where to locate this equipment. And again, I've been referring to this pre-work survey. You need to assess this before carrying the works out. So the use of insulation piercing connectors are intended for overhead distribution cables. This is what these connectors are designed for. They are type tested for aerial bundled cables. So in the example here, we've got double insulated tails. Now, double insulated tails have not been tested for this use. So if you, as the designer or the installer, elect to use these type of connections on double insulated tails, you would be using them outside of their product standard, and then you, as let's say the installer, would absorb responsibility for this. So again, using something potentially outside of what it's been designed for and what it's been tested for. And of course, if it's not making the connection it's been designed for, I guess it runs the risk of buildup of heat and may introduce a chance of thermal effects and potentially fire. So again, ECA would advise against this practice. So last point we're going to look at is consume units placed outside, and unfortunately no image for this one. So we're seeing more and more manufacturers are designing outdoor consume units that are offering an increased IP rating. So with this one, consideration needs to be given to the protective devices that are housed within that consume unit, within that enclosure, and their ability to operate in the varied conditions and temperatures. So we've got to think about the seasonal changes, the weather changes, the different times of years that could occur. So it's not just the IP rating we need to consider, it's the effects of the devices that are housed within that enclosure. Now, we're not ruling this out because we've just seen from the previous 2 points I've made that when adding EV charge point equipment to existing installations, it can be a bit tricky in terms of where to locate the equipment. So it could provide potentially a great engineering solution to a problem, and BS 7671 is not there to stifle innovation. However, it needs to ensure, you need to ensure if you're going to look at this as practice, that what you're doing is actually suitable. So you're going to need to obtain confirmation from manufacturers to confirm that the devices have been type tested within these enclosures. They've been type tested within the enclosures at the varied conditions that would be expected to be encountered throughout the different seasons, the different temperatures, and clarity that this IP rating is actually going to be maintained and intact. So manufacturers should be able to provide you certification on this, if that is the case, or a declaration of conformity to confirm that their equipment is actually suitable. So we're not completely ruling this one out, but we're just saying you need to really carry out some further due diligence if looking to apply this measure and confirm that what you're going to select is actually suitable. It's more than just IP rating that needs to be considered. I recently had a chat with Hager. I know they're currently trying to work on a solution and carrying out various tests. So Hager may at some point be able to provide a solution for this. I think that's unknown at the moment. And I'm sure other manufacturers are working away to provide solutions potentially for this. Okay, so that sort of concludes the main points for today. So I'm going to just finish off with a bit of a summary. So in outdoor locations, PME shall not be used unless one of the requirements within Regulation 722.411.4.1 are fulfilled. So some of the key bits out there, the possibility of an additional electrode being installed, connected to the PME system, and that providing a suitably low resistance. Other options were a suitable device installed to operate at certain conditions or operate during open pen conditions. And where relevant, a declaration of conformity should be appended to the certification and the relevant confirmation from manufacturers and information obtained as required. We also looked at RCDs, and the selection of RCDs for EV charge point equipment, it requires careful consideration. They shall switch all live conductors, they shall be of a suitable type, and they shall meet required standards. We also looked at some other earthing systems, and this may help to simplify the design when not having PME systems that are for use outdoors. I looked at the example around a TNS supply, where a reliable TNS supply was available with a dedicated maybe 11 kV transformer on site. I've also given examples on carrying out the correct notification process to the DNO, and this is a requirement, and we do get feedback that this is not always happening. Obviously, the DNO need to know what's going on to their network. And there are some things to potentially look at avoiding when carrying out EV charge point installations, or some stuff that requires some careful and further consideration. So just a reminder, obviously I'm part of the technical team, but we are more than just a technical trade association. We offer a wide range of support services to you at your fingertips. So there's some examples here on screen, from business and legal to health and safety and more. So we are available via our dedicated helplines, either on the phone or via email. So please feel free to contact us whenever required, and we can aid to offer support. So that's me for now. I'll sort of hand back to Omar to see if we've had any questions, and I'll be happy to do my best to answer those. And there are some links there available for some of the guides I've referred to throughout the presentation. Thanks for listening.
Thank you very much, Curtis. Fantastic presentation.
Cheers, thank you.
Just a quick word to our viewers before we jump into the questions, because we've got quite a few. So those three guides that Curtis mentioned, I've copied and pasted them into the chat here on the webinar. So if you're able to see those, guide to RCD types, guide to PNB systems, and the guide to use of consumer service cupboards, they should all be there. You'll also be getting an email shortly after this webinar, 1 hour after we end our session, and those links to those guides will be in there as well. So jumping into the Q&A, Curtis, I've tried forwarding these to you, so I don't know if they appear on your screen yet or not, but
can you take control back of the screen, sorry, so I can go out the presentation, or can I just escape?
Yes, should be able to do that.
Yeah, I'll just
there we go. So hopefully you'll be able to see those, but either way, I'll read them out for the audience as well.
Yeah, go through it. I'm just looking at the chat now. Okay, it's all right, it's very small. I can't.
No worries, I'll read them out.
Sorry, yeah, questions as a separate bit is in there. You go through it, read them out, and I'll go from there.
So first question here. We've always been led to believe that 50 volts is the point at which personal risk starts to become too great, and a lot of the calculations are based on this value. The question is, so how does 70 volts become okay for this value, particularly when it's an external installation with water in contact highly improbable?
Okay, yeah, so from my understanding, 50 volts has always been the hand-to-hand contact. So the 70 volts, I believe, is hand to foot. As far as I'm aware with that one. So obviously a bit further to travel, additional resistance, I assume, within the body.
Okay.
Hopefully that answers it.
Next question. Most RCBOs are SP plus N. Are these acceptable?
Yeah, so requirements of the regulation, sorry, SP plus N, single pole and neutral. So just to confirm on that one, it should be single pole switch neutral. I believe SP plus N, single pole and neutral. That may be just single pole without having to pull in some manufacturer's data up and having a good look. I wouldn't want to sort of commit myself to that one. Confirming your manufacturer, single pole and switch neutral, okay, which was the example I had. So what you've got with that is the overcurrent protections in the line conductor, which are sort of shown on screen, but the neutral conductor will also switch. So if you get a fault, it will disconnect the neutral as well. Just the single pole device will just obviously just disconnect the line. So I get exactly what you're saying with that one. Without pulling it up, I just can't think off the top of the head without having a proper look. So maybe just a probe to your manufacturer just to confirm, or maybe if you have a deeper look, it might provide a bit of clarity. But single pole and switch neutral is okay. But if it's just single pole and a permanently connected neutral, then obviously not, it wouldn't switch all the live conductors. Okay.
Great, thank you. Now we've got I believe these are more statements than or comments and questions, but feel free to add to them or not.
Yeah.
PME supplied property with external chargers. If the chargers have inbuilt RCD and open pen protection, we assume the suppliers don't need RCD protection unless the cable routing means it is required. Then we have, if the chargers claim to have RCD protection, can we assume these will be double pole devices?
Okay, so I'll go with the first one first. So I think that was charger with inbuilt open pen protection, I believe, and RCD built within. Okay, conversation with the manufacturer to confirm. As I mentioned, you've got to obtain the declaration of conformity for the open pen device. So you need that clarity there. I assume that it will probably be available off the manufacturer's website. With regards to the RCD, is it actually an RCD? Does it meet one of those standards are listed? So again, conversation with the manufacturer. They should be able to provide you relevant information to confirm that that RCD actually meets that standards, that it's been type tested and undergone all the tests of, let's say, BSEN 61008, and it meets that standards. So is it actually an RCD? And sorry, the second one was RCD. Can we assume it's double pole? I wouldn't assume, because I think someone pointed out a lot of RCDs on markets, well, depending whether it's an RCD, RCBO, or not, it's not necessarily double pole. Again, I would look to obtain more information from the manufacturer to clarify that. Hopefully that answers that one.
Thanks, Curtis. And last one here. There are so many new companies now EV chargers. Does the ECA recommend any that do comply?
I can't recommend. Sorry, I wouldn't want to recommend.
It's a slightly tough one. There aren't any that we recommend at the moment, but obviously we're constantly reviewing the information that's.
And then I'm sure we've got great commercial associates that may be able to help, but I wouldn't want to endorse anyone's products as such.
Yeah, I mean, the person asking a question is absolutely right. There are so many out there at the minute. At ECA, we're constantly reviewing the new information that comes out from manufacturers as these chargers come out. I would say to check out our list of commercial associates, all ECA commercial associates. ECA commercial associates are thoroughly vetted for the quality of the products of their products and services. So I think that would be a good place to start. But
and of course, as well, obviously, if you've got something specific in mind, feel free to call up the technical helpline, email in, and you can share what people have asked quite specific questions about specific maybe devices or equipment. If you share it in, and with the data, we can have a look and share back our thoughts that may be able to help. So, yeah.
Absolutely, yeah. If in doubt, give our technical helpline a ring. Best to approach these things on a case-by-case basis sometimes.
Yeah.
Okay, I think we can wrap up there. Thanks again, Curtis, for your presentation. Fantastic as always. And thanks again to our audience. So this was an ECA member exclusive presentation. So to watch the replay or perhaps share it with your colleagues, with your teams, you will need to log in to the members area. ECA website, it will be available there shortly. Okay, we'll leave it there. Enjoy your afternoons, and thank you, Curtis, once again.
Cheers. Thanks for everyone listening and the questions. Cheers.
Thanks, everyone.